The industry is undertaking exciting work and has ambitious plans to remove carbon from UK concrete and cement to complete the transition to net zero and beyond. It's not a simple task and needs a joint effort between the UK concrete and cement industry, the government and other industrial sectors. Manufacturers of concrete and cement are committed to deliver net zero and even go beyond that to produce net negative carbon products. UK concrete and cement emissions are around 1.5% of the total UK territorial emissions. That's 5 times lower than the global cement industry figure of around 7%. Early action taken by the UK concrete and cement industry has seen a 53% reduction in emissions from 1990 to 2018. And now, the UK Concrete and Cement Roadmap sets out a clear, viable pathway to cut carbon emissions to beyond net zero by 2050. Action by the industry alone won't achieve this though. We need behavioural change by clients, specifiers and the wider construction, energy and transportation sectors. Government investment and joined-up policy is also vital. This is the key graphic in the roadmap and shows very simply what lowers carbon. Look where we were back in 1990, mirroring the baseline used by the United Nations and UK government. Take a look at 2018, our reference point, and now consider what's possible when the carbon reduction levers are expressed as a percentage reduction of the 2018 emissions. Starting with indirect emissions, that's emissions linked to generating electricity, the key assumption in the net zero model is that the grid is almost decarbonised by 2050. That'll be achieved by efficiency savings and more power from non-carbon technologies. This will need a significant increase in the size of the UK electricity grid as energy and transport also shifts to electric power. Any additional policy cost measures should be proportionate for UK industrial consumers to ensure that they stay competitive in international markets. The overall net result is a 4% reduction in carbon emissions by 2050 compared to 2018. For transport emissions, the roadmap assumes that by 2050, transport will cut carbon by 80% from 2018 levels, leading to a 7% overall reduction in emissions. The development of low-carbon concretes and cements is leading with the action. In 2017, MPA Cement kick-started research into new low-carbon multi-component cements as general-purpose cements in the concrete standard. These can have 60% lower CO2 than current cements. A practical demonstration of these new cements is currently underway and are expected to become available later this year. Fuel, of course, is key on the road to net zero. There have already been big switches by UK cement producers. The model builds on this by assuming around 70% of the thermal input will be via waste biomass fuels. The overall result is a 16% reduction in CO2 emissions from 2018 to 2050. But this roadmap has to be delivered, and the MPA has taken early action with an innovation programme to develop fuel switching solutions for the sector. It's funded by industry and government and will demonstrate the use of electrical plasma energy and biomass in a calciner on a tarmac cement site. Hydrogen and biomass fuels will fuel the main burner at a Hanson cement site, and hydrogen will replace natural gas in UK lime production. The model uses carbon capture, usage and storage, or CCUS, to take up the remaining emissions after the early technology has been deployed. This will get us to net zero with a 61% reduction in CO2 emissions by 2050. Carbon capture might once have felt unachievable, but there's a huge amount of work underway in the UK and internationally. And government has set the target of at least 4 low-carbon clusters by 2030 and at least 1 net zero cluster by 2040. A number of cement plants are connected with these clusters: the Hynet cluster in the northwest of England, the South Wales cluster, and the Nexus project in Scotland. CCUS will be costly to deploy and has got to be done without risking the competitiveness of UK industry. Financial and infrastructure support will be vital for transport, long-term geological storage and reuse. Finally, the roadmap model includes some of the benefits of using concrete in carbon reduction. It's not always known that concrete captures and permanently stores CO2 through carbonation. That's in use, at the end of life, and in any secondary use. This results in a 12% reduction in emissions, taking us beyond zero in the roadmap. With some process changes in use and at the end of life for recycling, this can be enhanced or accelerated. Thermal mass associated with concrete buildings also saves CO2 by reducing the need for air conditioning and heating, again helping to mitigate the impacts of climate change. By designing buildings to maximise this feature, the roadmap shows that a further 44% reduction in those 2018 emissions is possible beyond net zero. To enable this, CO2 impacts should be assessed over the whole life of a building. The industry is aiming to go beyond net zero. The sector wants to be net negative by removing more CO2 from the atmosphere than it produces each year. Concrete will be a net zero construction material by 2050, and using it has the potential to remove even more carbon dioxide from the atmosphere. Low carbon concrete and cements are available today. The industry is leading with action and information to produce carbon savings and efficient construction that's fire resistant, long lasting and resilient.